Yeah, hi. Good evening, everyone. Welcome to the second session of this week. I am Atul Pratap Singh, one of the instructor for this embedded C course. I hope you have done C programming. So I've already done C programming course in the ES. So week 2, basically, professor have discussed about some programming language which we will use in this embedded C programming course. So I hope you have recapped the C programming. So they because there are many topics that will be used in the embedded C, basically embedded system. If you try to hands-on on some microcontroller. Okay, so regarding the course, definitely we are use one that Walk-V simulator, that is online simulator we have. Apart from that, you can also take this STM32 on Walk-V as well. We will use this STM32 or sometimes Arduino. And but if you want to start with the real hardware, then definitely you can start with this STM32. And on these second session on Thursday, so time to time, so this session basically we will try to conduct for the hands-on. So maybe 1 week on the Walk-V simulator and 1 week for the real hardware. Okay, so this is maybe alternative. So I'll also explain some explore some real hardware, that example on the STM32 board, and that ID we will discuss today. Before that, your C concept should be revisit. So as professor have discussed many topics in this week regarding the C. So what are the important things you should know? So and yeah, so that pointers, bitwise operators, at the basic programming function structure, all these things that definitely you should revise. So my first question is, if you have any doubt in the C programming concepts, then you can ask first. Okay. After that, I'll also discuss some basics of this STM32, that IDE board. Okay, and I'll give some basic idea of the uh, that IDE. Okay. Yes. So, any query, anyone? Any topic in the C programming which you want to revisit? Am I audible?
Yes, sir.
Okay, okay,
Yes, sir,
okay.
you are audible.
Okay, okay, fine. So, as that professor have also mentioned that pointer, if you are plan, yeah, now we are offline. Okay, okay, thanks. Yeah. Okay, so the planning, basically, if you want to use that C programming for the embedded system, basically the professor will discuss all the conceptual things in the lecture. Sometime, time to time, he will also discuss that programming uh, for some specific purpose, that maybe in Walk-V simulator or sometimes in Arduino. And in the finally course, you know that this course have the lab component also. So you will also come in the ITM campus, and where you can just work on the physical board also. Okay, but you can also purchase your board, because if you are learning something, that definitely you can just uh, uh, purchase some board. These boards are not too much costly, and later after completion of the course you can practice with these boards and you can explore more things. You can try to do some create some new projects. So that is just interesting things if you want to do, so you can purchase your own board and you can practice with this. Okay, so first thing is, what are the things important as a normal programming language: function, conditional statement, loop, variable data. These are the basic things. Okay, if you are doing the programming. But yeah, pointers and this bitwise operators, these are some very important concepts that actually normally used in the when you are writing the code for the embedded C. Okay, so because embedded C programming, if you're writing a hardware level coding, so definitely you have to interact with the hardware. That hardware means the memories. Okay, and for memories, you need for accessing the memory or interact with the memory, you need a pointer which actually access the address of the memory. And sometimes that if you want to so you will get a memory information. After that, basically, uh, during the programming you have to change the data on the memory. Okay, sometimes you have to check the data on the memory. So what that bit actually here we have some registers concept in the microcontroller. So each actually peripherals contains their registers. So registers are not nothing new. Actually, this is just a memory component that contains some specific 32 bit or sometimes more data. And each bit in this 32 bit actually have some specific meaning for that. If that bit is zero, that specific meaning is there for zero, and if it is one, that different meaning is there. Okay, so only that data we need to change, that data we need to read for some particular bit from the registers. So how you can check that if any particular bit of the register. Okay, so suppose register have 32 bits. So suppose you are checking the eighth bit in the 32 bit registers, and that bit is set to 1 or 0. Okay, you want to check this, how so that bit is actually contains 0 data or 1 data. So how you can check this? Or sometimes you want to change some specific particular bit. Okay, suppose you want to change the ninth bit to the 1, which was actually previously 0. So in that case, you need this bitwise operator, and that is actually very commonly used. Okay, so when we work on the hardware level programming. So we have the another way to write a programming language, write a program for the embedded C. So that each actually that microcontroller provides some abstract layer of the programming that actually provides some predefined functions. So sometimes we called as a hardware abstract layer (HAL) things. Okay, so where you need to just use their function and just pass the value, and the interaction with the hardware, that function will actually perform. You no need to worry about that how that operation is performed. You need to just use the function. So like this math library, you know that C programming math library provides some square root or this type of function. So you are just calling the function name and passing the value, and that function will return the value. Same things, that hardware abstract layer, this type of abstraction layer provide some direct function. So you need to just pass the register name or some data, something the required parameters, and the function will perform all interaction with the real hardware. Okay, so same way the backend actually predefined programs are written, and that programs are written in the C language, and that are actually that when you will call that function, that program will perform what will run, and your operation will be performed. Another things, you can directly write the C program without using this hardware abstract layer. Okay, you can directly write, directly interact with the C that hardware using your that C program. So for that, you should have good understanding of the microcontroller. So because of that, each microcontroller provides their reference manual, that user manual, data sheet, all these type of documents. So you can just go visit, you can visit the documents if you are using any specific microcontroller. So you can download their particular that reference manual or user manual, or you can understand their hardware specification. So I'll just explain some of the hardware today, show you, and that how we can read the data, how we can read the document, and what are their IDs actually. Okay, so what ID we can use? So we have this specific STM32. So if you can see, I have these two uh, version of this hardware, that STM32. This is one hard microcontroller I have. This is actually Discovery model. So the model name is also written here, STM32 F407G Discovery 1. So this is the model of this microcontroller. Okay, and another I have this Nucleo. Okay, basically this you will find out on that Walkme simulator also. Okay, this is also connected to my computer. So this model is Nucleo G47RE, that version. Okay, Nucleo model we have. This is also a STM microcontroller. So both microcontrollers are STM32 micro based on that ARM Cortex. I think processor is, I think, M3 or M4. Okay, so yeah, so these microcontroller I have, I'll explain some examples using these microcontrollers, basically Nucleo. So because Nucleo will also be available on the Walk-V, that simulator, you can also do the that you can also write the code for that simulator, or you can purchase any this type of version for you. Doesn't matter the same version, but you can purchase any version of the Nucleo series or any Discovery series. So actually, we want to start learning basic of the how we can write a code on this microcontroller, how we can perform some experiments. So that we will try to understand, and after that, using the documentation, all these things, you can explore more things in the controller. Okay, so first thing is that I hope this bitwise operator things are clear, pointers things are clear, because these things will be used continuously in the when we will write the program. Okay, so that part should be clear. Because of that, we have added 5 graded programming assignment in this week. So you can see the all questions are based on some this bitwise operations. Okay, so set bit or that check bit, this type of things. Some questions are also there in the your week that graded assignments. So you can that go through each type of bitwise operator, and just try to understand that how things are happening when you are using any bitwise operator, and operator or operator not operator, or these type of operator. Okay, so I hope these things are clear, that bitwise operator, or shall I revise some things on this, or pointer, or any topic of C? Okay, anyone, any response? All are clear?
Yes, sir.
Okay, okay, fine. Okay, so I'll just explore. I'll not explain any experiment today. For this, because now this course is just started. The basic things are discussed. So I'll explore the IDE, STM32 IDE, and I'll just give you some basic example how we can write a program, how we can connect the target. So basic how we can some debug things. Okay, so how we can check the debug features of these IDs. Okay, so let me share my screen and show you the controller, that IDE. Okay, so you can download this STM micro, that STM32 Cube IDE from the STM website. Okay, so in the Google you can simply type the stm.com. So that provide this IDE STM32 Cube. You can download the latest version and you can install in your computer. So that is the simple process, just installation. After that, so that IDE actually contains lots of features. So that will that built C compiler will also be added in this, and you can write C program also in this, and you after that you can create a project, and you can create your microcontroller also. Okay, so regarding the creation of basic C program, so let me you can go through after opening the STM 32 that Cube IDE. This is the simple option file. Okay, so file, inside the file option, where the option we have that like this new option. Okay, so you can create things like C, if you want to just write a C program without connecting your hardware or anything. So here this is the second option we have, new and C++ project. Okay, so when you click on
Sir,
the
can
C,
you share, please? Can you share your
what,
screen, sir?
my screen is
Screen share.
shared.
Oh,
My,
sorry.
my screen is not shared.
Yeah,
Yes,
sir, it
visible,
is
sir.
visible.
Visible, no?
Yeah, yeah.
Okay, so please check. You can just check. You can pin the screen. Okay, I've already shared
Okay.
my screen. Okay. So here, this we have these options. So you can select the first option, nothing to do anything, and you can create a next button here. And after that, you can select this min GW. This is a C compiler we have. Another compiler also we have, but normal C code we can select this one. And after that, you can give the name of this project here. Okay. So like suppose I'm giving the test hello world. Okay. And next, or we can click on the finish. So it will take some time, and after that it will create a file. Okay. So now here, you can see this folder is created, and inside this there is one include file we have, and we can create a, after that for C program we can click on the right, and after that we can create a new and source file. Okay, so source file means .c file we are writing here. Okay, similar way we can also create a header file. So header file is also required if you are working on the driver code implementation. So driver codes are normal codes basically which directly interact with the hardware. So that we will also just we will also learn in the next sessions how we can create a driver's code, so that code will directly work on the real hardware, that hardware of the microcontroller. So I'm just writing a source file here, and source file name we can give anything, so like main.c and finish. So this is simple code here, and after that you can write your C code, like has include and that stdioh. Okay, like in main, and after that you can write anything like print f hello. Okay, return. Okay, after that there is one option here we have, or you can also click on this project and you can build the project. Okay, so you can see you will get a message in the console that program is have run successfully, and after that you can run the project. So there's one option run, and you can click on this. One second, this is unsupported world configuration MCU. What this, let me check. Run edge STM. Okay, what is debugger? WT main build configuration MCU required to debug. Okay, so let's check this. Some error is there. So okay, why this is not connected? Okay, let me open another switch. File switch workspace host workspace like one second. Yeah, I'm restarting this. It takes some time for the restarting and opening. Okay, so just wait.
So, one doubt.
Mm-hmm.
So, what's the difference with the simulator and IDE?
ID actually that provide all the features like that editor as well as the debugger, and that compiler, all things are inbuilt in the same that software. That is actually IDE. Simulator is also very uh, s- similar things, but that is some for a specific purpose, like if you are working on MATLAB or something type, so some specific target that actually perform some specific operation. If you want to run some that electronics type of experiment, so they provide some that virtual things. So like in MATLAB or some another types of simulators are there, you can create a virtual things, and then you can run, okay, without any real hardware things, okay. Like that walk we have, where no real hardware is there, all things are actually virtually created. You can connect the circuits virtually, okay, all things will, you can work on the software itself. So and you can run and test, okay. But here you can connect the hardware, you can directly perform the things. And another ID we have, like that that some IDs actually provide the multiple language support, like VS Code that supports the multiple language, all these things. You can simply install the compiler and you can perform the things. Okay, so yeah, this is also created like this. So let me run this. I think the setting is maybe same. Huh. This is working fine. So you can see the similar project we have created here, project explorer. So first time when we run this, let's open this build project. Nothing to build. Okay, so that is already built. So let me create again. New.
Sir,
Mm-hmm.
sir, here what happens? The value of B, sir. A right shift 2 means
This shift to na. Okay,
yes, sir.
okay. So that we will discuss. Okay, so here shifting, that operation is performing on the bit actually. Okay, so what is the equivalent binary of this 8? Okay, so we will shift the bits two position to the right. So let's just understand that. What is the binary equivalent of this 8? So that is actually 1000, correct?
Yes, sir.
Okay, so this is the binary equivalent of this. And when you perform this a right shift 2, so that one this bit, all bits will be shifted to the right, two position to the right. So this will become a like this 00 and 110, sorry, 0, correct. This is not a rotating, this is shifting. Okay, so that means all bits will be shifted. So right, suppose if we have like 1 here, so that 1 will be lost. Okay, that will not come into the first position. So this is just a shifting, not rotating. So 0. Now you can see when we shift all these bits two position to the right, what binary we are getting, and what is the equal decimal for this? This is
2, sir.
2, correct. So when I run this, you can see what we are getting, 2. Okay, so this message is different things. So B we are getting this 2. And let's 1 byte. Okay, so we have this like 0000. Okay, and let's make this as a different side. This side, let's see what we are getting. 32. So in this case, what happened? Now this one is shifted to this position. Now this position. 0. Okay. So now this become a 32. Yeah, someone raised the hand. Nilesh.
Sir, I wanted to ask that in the lecture, professor told us that microcontroller is self-contained. That is, every aspect, the memory, the processing unit is content inside itself, the microcontroller.
Hmm.
So, as we see also in the previous session, you showed us the that board, STM board. So what are those other things on it? We can see the black microcontroller thing with multiple pins, but what are
Huh.
others?
So okay, 1 second.
Can't we run it directly?
So what microcontroller have actually? So let me explain that. So basically, microcontroller is a collection of that processor. Okay, that processor first. Okay, so this is the main unit and memory, and we have that peripheral, that we have clock, we have bus, these things. Okay, so these are the main component of the microcontroller. So this is the main unit that performs all the operations. These are the memories. Memory, we have different types of memory. One is flash memory, another is RAM memory. Okay, and peripherals, we have many things like GPIO, general purpose input output, and we have another also the I2C, and there are many A to analog to digital convert ADC, and there are multiple that hardware we have that have some specific purpose. Okay, like GPIOs, we have another peripherals we also, so that have some specific purpose to connect the output device, perform some operations, some serial communications, and okay, so that is the purpose of these peripherals. Clocks actually provide the frequency, that pulse, okay, to the microcontrollers. Because of that, actually each of the part of microcontroller works based on that clock frequency. And bus are just a communication channels between each part. So all these part actually combined with this boards, which I'm actually showing you on this part. Okay, so that board have, so in between these one box is there. If you can see, this black is, this thing is there. So that is actually the main processor of this microcontroller. Other all these things, that memory, all these things are connected, and connections are there, pins are there, so that are just used for the to connect the output another things devices to the microcontroller. So, and this actually works as a like as a small computer things. Okay, so we will upload our code in this memory, and that is actually flash memory. Okay, and that code will run forever actually. Okay, once we will start, so once we will upload in this, so that code will run forever. And that code will be designed in this way, so it will take some input, and based on that it will perform some task, it will return some output things. And in between, so you can see that if some specific small hardware sometimes have the touch facility. Okay, so when you just press the touch button, and that device is actually off. So let me show this. If you can see this small table lamp. Okay, so this is the one example you can see here. There was one touch button is there, so some code is actually running inside this. When I'm just pressing on this, that light is turned on. Okay, again when I'm just touching this, then some that led brightness is increased. Okay, and now when I again touch this, you can see what happened. Again brightness is increased, now this is turned off.
Because it's always running in the background.
So this some microcontroller code is running inside this. So that is actually pre-written in this devices. I'm not but pressing anything. So I'm just simply touching. So some touching sensor is there that just read the sensors. That sensor read some input, and based on that, that change the state actually of the code. Okay. So some conditional statement are there. Some input is that some input that first time if that some input received, that change the state to the another position of the output. Okay, next second time when we are same touching the same sensor, so it will change the next state. So in this way that code is running in the device forever. And based on when we are performing any when we are pressing something, or when we are performing any operation, so that will actually perform their task, which is predefined. Okay, so in this way, this is actually a very small unit that can perform, that can run the code, okay, which is actually stored inside this memory, that can run the code. And
Can you show that in the diagram, the
hmm,
picture on the website, so I can connect well, sir?
hmm. Okay, so this is just a overall structure of the microcontroller, so which we are saying this, and some microcontroller also provide the debugger circuit. So that debugger just nothing is actually a connection where that debugger actually can be communicate to your IDE. Okay, so what this microcontroller is doing, what are the memory things, all these things are there that have what data is available inside the memory, all things you can debug through this debugger unit. And this debugger unit will provide all the data to your computer, or IDE, where you are you can interact with the real hardware at the running time. Okay, so you can see all the data, also you can see the all operations, how the operations are performing, all the things you can check through this debugger. Okay, so that circuit is also inbuilt. These are microcontroller circuits which
When we connected to the board in order to program it, so where do we connect it? In the that
huh.
peripheral section or the debugger section?
First thing, what so you can see this another board which is connected to my laptop, okay, by the this USB cable. Okay, so this is connected through the debugger, and this is also providing the power to this microcontroller. One second, just give me a minute. What happened? Yeah, sorry. Okay, so as I said, what I was saying that, huh. So as I said that this microcontroller is connected to the computer, and okay, so by this USB it is also providing the power to the circuit. And I'm opening this in the IDE. Okay, so how we can open the hardware in the IDE. So let me
Sir, just you have shown already STM32, na sir? What is that?
yes, STM32 Nucleo board, this one, and another board
Nu-
which is not
Nucleo
connected.
board.
Nucleo, that version have that this is Nucleo G7 G474RE model. Okay, actually these are the series. Nucleo is the one of the series of STM32, and that have multiple models that have some different features. Okay, same have another Discovery series on the same STM32 controller that have also some models inside that series.
So, sir, anyhow, we will get simulator for all of these series, na sir? All of
Ha,
these
so
models, na?
so this IDE which I am showing you, STM32 IDE, actually it supports each model of the STM. Okay, because this software is created only for the STM board, and it is updated time to time and supports each type of board. If you purchase any board, that will support this IDE. Okay, so I'm changing that my another location. So next time we will create a some experiment on this, but I'm showing you how we can connect this. So So these electronics experiments are very interesting if you works on that and it works actually. Okay, if you trying to do some experiment and your experiment is working successfully, that it will increase your confidence also. Okay, here how we can connect actually. Okay, so when we click on the file, after that same new project, and we select this now STM 32 project, this option. Okay, when we click on this, take some time, and because I have opened this ID after many long time, so it is updating me. So you can see some update is happening. Open or not? What happened? Hmm.
Sir,
Hmm. Yeah, Nilesh.
so what I understand is what do this ID does. What does it do is when we write a C program, it converts it into the specific sequence of zeros and ones, which the microcontroller recognizes as a specific commands to operate, and
Mhm.
it's
Yeah,
specific to the.
I'll tell you what is the process of the things. Okay, so how the file is actually converted. How the file is converted. So for I'm giving one example. I'll showing you some example for that. So you know that there's one compiler we have online GDVE. Okay, so this is for where you can perform multiple type of programs. Okay, here one program is written a hello world, and here you can select multiple language. So I have selected this C. Okay, when we running this, so that all two operations are performed. First is the that compilation and then run. Okay, so during the compilation process, what files are created actually? This is basically C compiler. Okay, this code will directly not we can upload. That file is different actually. So here you can see when I run this code, you can see three other files are also created. And when you will run on this online GDV, these things, that program will only return the output, and these file you cannot see. So we have to do one setting to see this. Actually, I have already done this setting, but first time if you want to use that, that setting is not there. So what happened actually? Just go to the setting of option in this online GDVA and just click on this extra compiler flag. And when we open this, so there is one extra compiler flags are simply dash, that is minus keyword, dash save dash temps. Okay, so this actually saves the file which is created during the compilation process, and just click on the OK button. I have already done this, so because of that it is saved. Okay, when you just want to check, you have to write this. So you can just note down this dot dash save dash temps. Okay. After that, when you run this code, you can see these files are created. So what are these files? So this is the source file which you have written. Okay, this is the main language file, C programming high level language, which we are writing. Only this five six main lines are there in this. But when we compile this, so then next file is created, this a main.i. This is the preprocessor file, preprocessing file. Okay, so because in the where in some library, so this is defined inside this in standard input output. Okay, stdio.h. So full definitions are given inside this library. So when we will compile this, so that library completely will include in your program. So that is actually this one. Okay, so this is the complete file. Here you can see this is very big file. There are lots of programs are there, and in at the end of the program you can see your code. This is the your code. Okay, which you have written. and before that these 743 lines are added. So that's are related to your include library, all that things are added. And in this code you can find out that you can search like that search feature is not there, but you can search this printf prototype function is defined. Okay, and you are passing one parameter as a string in this, and that function will take this as a parameter and will perform some that hardware operation, so that will your output will be print in the output that console. So this is now next step when you compile the program. So this file is created, that is actually processing file. After that, next step is this assembly language. So now your high level language is converted into a assembly language. First step is pre-processing, then after that it is converted into a assembly language, that is actually lower level language, we can say that, and which is more closer to the hardware or that computer. So here you can see each steps are defined in this type of steps that move. And if you remember in the C programming course, we have discussed little bit about the assembly language in week 2. So that move add function, and we have mentioned some example on this assembly language. So you can see now this type of code is converted into this assembly language. Now this is not very easy to understand. You can see sometimes strings which you have passed, this is here, print statement is here. This is not very easy to understand. Yeah, so you can also learn this course. Assembly language courses are also there. You can learn this course and you can understand the meaning of each instruction, then you can easily understand these steps. Okay, but this is not easy as much this is high level language. Okay, so only you have written on this code, but now this has converted into in this assembly language. Okay, so now this is the next step. After that, this assembly language will be converted into a machine level language. Okay, that is the real hardware language. So that is actually binary language. So that this is o main dot o. Now this is also a not proper readable. Okay, this is converted, this is just a object file actually, and this file is actually runs on the hardware, and then your output comes to the console. Okay, so this is the complete process of the compilation in C language. Similar that compilation process happen on your embedded system. So okay, so that is open now. So you can see when we click on this microcontroller page, so this type of page is opened actually. Okay, and here first thing you have to connect your microcontroller. Okay, so before starting the creation of project on the board, you have to connect your board on the computer system, as well as you have to update your software. Okay, so if any updation is pending, so that should be happen, otherwise some error you may be get regarding the compatibility. So here you have to select the board selector. Okay, so this is the one option you have, board selector. So you have to click on this. Still I think it is okay, board selector. Okay, and after that you can, there are lots of boards you can see nucleo series is there. You can, there are lots of boards available with the same nucleo series. Okay, now discovery series is also there, I think that you can also see. And B, okay, discovery is not look okay, this is disconnect, so it is not also showing. Otherwise nucleo board is, you can see which model you have this, so you have to select that model. So let me type this. So what is this model? So G4 nucleo, first thing G4 G2. Okay, I was typing here. So G47RE. Okay, this one. Yeah, okay. So my board is this one, G47RE. When I click on this, you can see this board is also, you can visible here in the diagram. Okay, and here this provides the documentation also. Okay, so when you select this board, when you click on this board, now documentation are also available. Docs and resource data sheet, you can download all the documentations from this portal. Okay, so that are actually helpful. After that you can simply click on the next button, and when you click on the next button, it will ask for the project name. Okay, so project name, You can give any name like test 1 to 5. I'm giving just a random name. Okay, test 1 to 5, which is not created before. Okay. After that, C language we are using. We can also use a C++, but we will use C here. And targeted binary is the that executable. Okay, so this we will created this type of file. And also these are the two options: targeted, project type. Okay, these are two different options we have here. If you select this STM32 cube, so this is actually a that IDE features that actually provide a GUI to configure your board. Okay, without writing the code. Okay, without writing the complete code. So if you select this option, it will open a new that GUI interface where you can see your microprocessor complete board, and you can configure all the settings, connections, just by the click. Okay, mouse clicks, that feature. But that things we don't want to do at the initially. Okay, we want to understand from the basic that direct hardware basic level code. Okay, so but if you select this, you can simply click and configure the things, and when you click on the that save icon, that will actually generate the code. That will automatically generate the code. After that, you need to write very small code in that inside that using the HL library. But if we select the empty, it will open a new fresh project. Okay, where you can write a program from the basic level, first level. Okay, so click on this finish button. So I'm able to open this because of my board is connected. Otherwise, if your board is not connected, so that things will not be open. Okay, where it is open? Test this one. Okay, so I'm removing this file. This is the old one. Yeah, so test 1 to 5. This file, you can see this required files are created. INC is the included for header files, src for the source file. Okay, and this the main.c. This main.c is the file where we will write the code, and some predefined code is there. And this is the main. You can remove this because this is the by default, and you can remove this component. And now you can see some code is written here. So that is the same library, and this is the integer library which professor have also discussed in the Week-2. Okay, has include stdi.int.h. Generally we not print anything in this type of program when we are using that board. So we are not using this that input on stdio.h. Okay, if you want to print, you can use. So after that, this for loop is there, so that loop will be run forever. Okay, so that microcontroller code actually runs forever. And same type you can also write while loop, and you can write a code inside the while loop, so that will run forever and just pass the true condition for that. So in this case, this is the basic code, and let me open one the predefined code. So that is simply a hello world. Mm. So similarly, another project we have already created. So source files are there. So let me open this one. Okay, so now we can write like this is just a debugging purpose based. Okay, so I am not how we can upload this, okay, on the board. So let me just close the previous one. So now this is simply a very similar code in the main.c where the print hello world message is there. After that, when we click on this project, so this is also a project that is name is hello that 001 hello world. And I'll click on the project name, and first thing is the build project. Okay, so when I'm clicking on the build, so this is file. Yeah, for microcontroller, if we are writing a code for the microcontroller, so this ELF file is created actually, and this is the supported file by the microcontroller, and this is the executable file that will direct. So this is the machine, basically a type of machine code, and that code will be uploaded to your microcontroller. So this .elf file will be uploaded to your microcontroller. So this is also a process, the compilation process completely. When we are clicking on the build button, all the compilation process is happening. And during the compilation process, if you any code have any error, you will get an error in this message here. So warning error you will get. If all things are okay, then this file will be generated. Okay, this file will be generated. And if you want to upload this file on the controller, so you have to click on this, and you can first thing you have to just click on this debug as. Okay, here you have to uh, first time this will ask for some settings. So debug configuration, if you want to debug something, so here we can perform many debug things. Okay, so you have to click on this first option when you open the first time. So after that it will show your the project. When you click on the project, these are some very predefined settings are there, so that is already pre-written. So you can see this is the main file, elf file, that will actually be uploaded on the board. Okay, so in this case this is already set. Okay, you can also change some another settings inside the debugger startup, these things, but this is already predefined, no need to do anything. Yeah, debugger things, there is one feature swd, this is a serial wire viewer. This is one feature. If you want to like print something, because this code will run on the board and we have some print message here. So how we can check that board is actually printing correctly or not. So what we can do, we can enable some setting, this like swd, and this enable this serial wire that viewer, and this, enable this setting. And after that we can apply and then close. Okay, and once this setting is done, then we can run this code in the in the debugger mode, as is like simply select this stm32c. Now you can see this is, you can see my this is now blinking. Okay, this microcontroller is blinking, so that means this code is now uploaded to this board. Okay, after that, once the blinking is stopped, that means this code is now uploaded successfully. Okay, so this code is now running in this board, and you can see on the board download verified successfully. It also provides some basic informations on the console, and you can see this console information. It will provide some other address regarding this board information. Okay, so this, you can see this is the board name, what is the swd frequency, and address also it will provide what is the address where this code is actually stored, and this type of detail it will provide. So that details are coming through the debugger. Okay, so that debugger, which is a part of the microcontroller, so all these details are coming through the debugger to the computer, so where that things we are actually able to see here. Now this downloaded verified successfully, so that means our code is now successfully uploaded on the board. And because this is a debugger, this is not running right now, this is stopped on the board. Okay, you can see now this first instruction of the main function, this debugger will stop the code. Okay, now you can see the corresponding assembly code for this. Suppose this code, now there is one option inside the window, and inside the window show view, you have this disassembly, this one. Okay, when you click on this, you will get this window here, and you can see corresponding that assembly code for this on the microcontroller. Okay, so that this deassembly is for, and also it will show the break point where this break is now happen actually on the print statement. Corresponding assembly instruction is this. Okay, and each assembly instruction have some code which is predefined, and registers you can see R7, R3, all these are actually registers which are actually inside the microcontroller memory. So you can see this assembly code, as well as you can if your code have some variables or all these things, you can see all details inside this variables. So all comes under this features show view. So there are lots of you can also see the memory browser, you can also access the memory browser. Okay, so there is a memory browser option, and registers you can also explore each registers data. So register, it will show the all registers as well as the value inside the registers, you can see. So all these registers are actually microcontroller registers that are actually inside the memory of microcontroller. So you can see the data as well of the each microcontroller. And in the memory browser, you can see you can put the address, you can put any memory address, okay, of the microcontroller, like 0x 8 0 0 0 0 0 1 2 3 4 8. Okay, let me open this. Yeah, so you can see I have put this one address. This is actually a flash memory, code memory, okay, that is actually a non-volatile memory. If we turn off the power of this board, your code will remain exist on the board. When you will again turn on the power board, that code will start running again. So that code is all that is exist in the permanent memory. We can say that that data is stored, not permanent, but that is actually like a non-volatile memory. So you can see this is showing all place now. This is not only 80, this is the starting point, but you can see the data. You can select the option like columns, how many columns you want to see. So that 4 columns, that you can change the static cell size like 1 byte. uh, okay, so it is showing now each location. You can see if you are scrolling, it is showing the memory each location, and this data is coming in different format. So we have uploaded very small data, so because of that most of the locations are empty. But when you will work on the real experiment, you can see the data as well, but that data is actually in the form of that binary things or these things. So that will actually not very clear, but you can understand that. So let me, yeah, statics hex, yeah, decimal. So you can also change the type of data, so like hex, decimal, octal, binary, which form you want to check. So in this way you can see the data also if of the each memory locations. And to check this code is working perfectly or not, so you have to set that serial wire, that viewer enable, and that feature will be open from the same window and show view. And inside this swv there is one option, swv itm data console. Okay, when you click on this window will be open in the lower side. Okay, html. And here you have to setting something. So that setting is just only you have to enable this port 0, because our what we are printing, that data will be come through this 0 port serially. Okay, the all character will be come on this port through the debugger to the computer. Okay, so that we are enabling only. After that we are starting. Okay, so when we just start running, you can also run step by step. So from this debugger. Okay, so step into, step over, all features are there. So when we click on the resume button, so this code will run from this breakpoint completely. Okay, so let run this code. So now you can see this hello world message is printed. So this message is not directly printed through this compiler. Okay, this hello world is printed on the microcontroller, and from microcontroller is sending this data through this 0 port to this IDE. Okay, so that hello world is now printed. So this feature is useful if you want to trace some things in your code and trace the data in your code during the flow, or otherwise you can also explore each registers things. Okay, so this is the one debugger things you can use. There are lots of features available to just access all the things, debug things, thing. Okay, and let me open one that manual also for this. So I have already downloaded this. So there are two types of there are many types of document. Basically this, there is one reference manual of this series. Okay, so this is actually a common series, nucleo 1 G, g4. And reference manual is there, that user manual is there. Okay, that provides some all details of the board and purpose of each part of the board like this. And so these are two main important document. Sometimes other documents are also there, that data sheet, all these things, but these are very common. We will use in our next lab session for the experiment to understand the memories, all these things. So now when we open this document, you can click on this menu, and you can see system and memory overview, and all options are there. Okay, so GPIO, general purpose input output, so where we can pass the input through some pin and take the output through this pin, so that pins are there, GPIO. And each that peripherals, okay, which I'm saying, so each peripherals details are given inside this. Related registers are also given. So you, if I take the example of GPIOs, that are very general purpose input output. So if I open this, you can see GPIO registers. Okay, registers are simply a memory. So when I click on this, so that registers are started at this point. Huh. So you can see GPIO registers. Now that is a memory from some specific point, and each registers have 32 bit. So you can see each bit is defined here. So each 0 to 31, this memory. Now these have some pin actually. So GPIO have some pin. For each pin, 2 bits are assigned. So mode 0 like this. Okay, mode 0, that 2 bits are assigned for pin 1, like, okay, these 2 pins are pin 2 like this. Okay, and based on these 2 bits we can decide the mode. Okay, so if we set these 2 pin for any particular pin, we have to set 0 0, that will work as a input mode. If we set these bit as a 0 1, it will work as a general purpose output mode. If we set this 1 0, that will work as a alternate function mode, analog mode. So that means based on this bit value, all things are defined in this manual, and these are very common for each type of series, or most of the time these things are very common for most of the models. Okay, so very rarely some change are actually happen, otherwise most of the things actually remain same in the models. So GPIO, you can see this is the another register. So that means this first 32 bits are complete, next 32 bits are defined for some another purpose. Okay, so this is the second register for this GPIO, that is output type. Okay, so what type of output we are providing, so all details are given. If we set 1 bit, that this is output push pull, that things will be discussed in the week by week. What is this push pull, open drain, all these things will be discussed week by week topics. So all these so each peripherals have these registers. Registers are simply a memory, and each memory have some specific purpose, and where each bit is also have some specific purpose, and we have to set these bits um, for our task. Okay, so these registers you can understand for the peripheral. You can also understand the memory. Let me open the memory structure. So so you can open this memory page and you can see the complete memory representation. So you can see this is the memory. So code memory is basically started at this location 0 0 0. This is code. There's one flash, one more is there. Let me open. Here you can uh, okay. So yes, this is one common diagram. Okay, so what a type of memory is given. So here, huh, code memory is started from this address to this address. After that, SRAM. So this is the RAM type of memory. So RAM range is also defined from this address, and then SRAM 2 is there. So peripheral memory is started from uh, peripheral memory is started from this location. Okay, so each part is given. Yes, Avas. Someone raised the hand. Okay, so this documentation is now giving the information of memory locations for the each part. You can see flash memory, all details are given from this address. After that, you can also see all the things in detail. So like GPIO, as I said, GPIO, general purpose input output A port. Okay, so this is port A. So we have multiple ports on the board actually. Okay, so where each port address is starting. So like this is the starting address of GPIO A. Now this address is actually the address of registers. So suppose GPIO have 10 registers. Okay, for each GPIO. Now this is the first register address. Now each register have 32 bit. Size, so that just add these four value inside that, and that is the continuous thing. Okay, so that means 48000000 is the first register address after 32 bits, so that become a 00004. Okay, 4 into 8, so that become a total 32 bit. So you can also if you know the start address, you can calculate the registered address also. First registered address, just add 32 bits. Second registered address, then add 32 bit. Third registered address, like this. So in this way you can understand the each address of the peripherals. Same way you have the clock frequency, that AHP. These are actually type of buses. AHV1, where the hardware are connected. Okay, so there are multiple types of the bus in the circuit, and each bus, different type of hardwares are connected. So you can see which type of that peripherals or that component is connected on which type of bus. Okay, so that you can see this is some timer related things. uh, okay, and so all complete documentation is given. You can check the address, and we will work from the next session. Okay, so we will just implement the LED turn on or off based on this, directly on the hardware level coding, without any using any abstract layer things. Okay, so in this way you can see the understand the addressing, memory mapping, and you can figure out that which actually area you want to access. So this thing you want to you can check from this. User manual is also provide the that information of the board. So you can see if you can check the pin configuration, that connections. This you can see these are the microcontroller, how the connections are happening. You can also connect Arduino through this on this board, so that also provide the Arduino support. And this is the pin point. Actually each pin or devices is given, you can understand this. So if you are connecting Arduino, then pin number will be structure will be different. If you are directly using the pin, then pin name will be port will be different. So that all the informations are given on this. Okay, so you can see the numbering like RX0, D1, D4, this type of numbering. This is just a pin. And same parallel things have some connectors. So through this the Arduino board is connected, so that pin name will become a different based on the Arduino connections. Okay, so that things you can understand through this manuals, that user manual. You can just understand that where LED is connected, which pin LED is connected, where this push button is connected. You can see this blue button, this is just a push button. Okay, when we click on this button, some input is actually passed on some pin, that high or low. So that which pin that this is connected, all details you can find out on this user manual. So each actually microcontroller have this type of documentation. And initially you will find some difficulty to understand this, so because of that we will perform some experiment directly from this document on the board in the next session. And we will see how we can read the things. Okay, how we can check the data, and we will perform our task. Okay, so these documentation are required, so you can explore a little bit more on this. After that we can write the code in the same main function. So same here. Okay, and now you can stop this. So let me terminate this, because now this is running on the debugger mode. If you want to run as a completely, so you have to simply click on this and run as. Okay, now debug as actually provide the feature of access, all these things. You can run the code step by step, you can check all the step things. So that means you have the all control on the running. But run as means that code will completely install installed in your board, and that will run on the board. And now you cannot access. Okay, at the running time. So when I click on this, so now the connection is happening, same the code will be uploaded and will start running on the board. Okay, download verified security setting down. Okay, so now if you have performed any task on the board, so that task will be start performing on the board. So that we will see in the next session, that LED, all these things can input output things. So in this way, these are the interface. This is the IDE. You can just start exploring this. If you have board, or if you have not, then you can purchase and you can export more. Okay, so if you perform hands-on on in this course, definitely you will like this course. Okay, otherwise definitely theory is just for learning. It will not give you a proper knowledge for the, you cannot perform the things. But yeah, if you explore hands on, definitely you will understand all theory also very well. Okay, so this is just an introduction in this first session. Next session maybe that some walk-v simulator that there will be there. Then next session I'll explain some physical board experiment. Okay, so you can
Can
understand
you
if you
explain serial wire again?
serial wire input.
Yes, sir.
Huh. So serial wire input. First thing you have to write this code, and so this code is already written here. For setting, actually, first time you have to when you have to click on this debug as you have to click on this debug configuration. Okay, so after that, uh, you have to select your project, which project you have opened here. After that, inside the main function, this is the predefined features are there. Uh, Inside the debugger option, in the second option, you have to enable these settings like SWT. Okay, so this is one you have to enable, and after that you have to click on this. Okay, this serial wire viewer, this you have to click enable. Okay, and so when you will click on this enable button, this will some frequency, clock frequency is required through the for the communication. So that actually will be filled by default when you will click. Otherwise you can fill also, you can change also. And after that you have to apply this. Okay, and after apply, just close this again, debug this. I think something is changed. Okay, don't say. So after that, when you click on the again debug as, okay, so debug as, now you have to select this STM32 application, and this code will run and it will stop at the first instruction of the main. Okay, now you can see. So this another. So you can see some breakpoint is now applied here, and this code is now stopped at this point. Okay, so he after just stopping at this position, you can explore the things. So you can open this window and show view. There are lots of things are there, so you can check the assembly code for this corresponding each line by line. Okay, and also you can check, you can just run the code step by step and check what are the corresponding that assembly instructions for that. Okay, you can open the memory browser where you can check the data on memory. Okay, registers. Okay, if you are working on any specific peripheral, what are their registers, and each registers, what that registers have the data. If you have the address of that register, you can directly put the address and check the value on the register. Okay, otherwise you can select the registers on this window. So first time this all that window will not be open, but you can open from this so view. Okay, you can open all these things from here. And if you want to see the serial wire data, so you have to open this feature, so SWV, and inside this SWV, this last SWV item data console, you have to click on this. So this will that view will be open in your near to console, and here you have to enable the setting this like. Okay, so you want to read the data from this port 0. Okay, so that debugger is actually provide the data from this port 0 pin. Okay, you have to enable this. Okay, and just click OK. And after that, if you're not getting any data, so you have to start trace here. Okay, so that is already running now. So after that, when you will run this code, so let you can go step by step also. So let step into, you can see when I enter into the stats, it is now moved to the next instruction, for loop. Okay, now this instruction is executed, this message is passed to the our board, so it is now printed. But you need this slash n to see the output. Okay, if this slash n is not there, then it will actually will not be visible, because it will actually that your that controller will actually will stop at this same line, so that will not be actually visible here. So just put this slash n line if you want to print something, and then it will be printed here. Okay, your cursor is now moved to the next line, so previous things will be displayed here. So now you can run this step by step. Okay, and see if because I don't have any another instruction, so this now will run on the same steps. Okay, for loop.
So when we print any string,
Hmm.
so it converts into the corresponding binary sequence of the ASCII of,
Yes, yes.
for example, here hello world, and it will output it to the port 0.
Yes, yes. Okay, so let's stop this, and we have, if we are changing something, we have to build again. Okay, because this ELF file is actually have to change. So now we have to click on the build project, and that again ELF will be updated. So now again debug. Okay, debug on directly. You can do this. Okay, so now you can see this is stopped at the first line. And let me open this data console point, and now just move to the step wise. Okay, so first step is written, so hello world is printed. Next step, if it is print, so next line is printed. Okay, and now this is for loop, and this is actually, this colon is there, so it will stop actually. Okay, so then it is finished. So in this way, or you can resume completely, so or you can stop this termination. Okay, so that will stop.
Here for in bracket semicolons, what we doing, sir?
So this is type a loop actually, where we are not passing any initialization value, not condition. So that is work like as a infinite loop. Okay, you can also write like a while, that this type of thing. So while that condition one, and just like this. Okay. Generally, when we want to perform some experiment, we always write our code inside this while loop. So this is now true condition, and your code will run continuously. It will not stop. So in your that Mac board, actually this code will run continuously, and your task will be performed. So we always write the code inside the infinite loop for the microcontroller. Okay.
Sir, can you show the output of that printf statement, hello world and hello embedded C programming without the serial wire interpretation?
No, this is now this is a project which is created for the that board actually. Okay, so that will output will be come on through the board. If you want to
Yeah,
just
only on
simply,
the board. What will we see if I receive from that port? Without interpreting, we will be receiving a sequence of zeros and ones only now.
so that will actually convert again into that the text. Okay, so what I've seen is at the if I running this code, you cannot see anything, but at the that debug step, that debug which we have done, that debug. So at that time, actually debugger actually provide this input. What we are printing, that will be comes. So this is save. That output will be come through the serial wire input. So that data actually that will be passed to the debugger, and through the debugger it will come to the IDE. So inside this ITM data console, you can see the data. So you can resume the code completely, and you will see this. So this output is coming from the board to this IDE. Okay, through the debugger. So to reflection some experiment things, so that we have this input output pins. We want to give some input through one pin, we want to see some output through the pin. That experiment we can see through some indication on the board. So like we can connect some LED. Okay, and LED, we are pressing some button, that LED will turn off. So that code will be written, we will written the code here based on that our purpose, and that will be uploaded on the board, and board will perform the function according to our program. Okay, so that we will see in the coming sessions, so how we can connect the things. Okay, but this simple print statement is just for the debugging purpose. Okay, you can check the things. If you're writing some code, you want to check some data value in between, so you can put this print statement and you can use this debugger, and you can see. But on the board you cannot see this type of output, okay, because the, yeah, you can see, but you have to connect some that display unit, then you can see LCD or something you have to connect. Okay, so some that we have some we need some hardware to display the output, so this that we have to connect to the board, then you can see that message on the board, on that hardware unit also. Okay, so this is just now a idea of the how we can create a project or C project. Basically you can create, as have I already show you, that is simply a C project. You can click on this button and new, and simply create C++ project. Okay, this is not a that board project, this is just simply a C program. You can write and you can run like this. Okay, so that output will become directly on your editor. So that will work like as a compiler, C compiler, and like we are performing on this online board this year. Okay, so without interface, and you don't need to connect the board also if you are creating the C++ project. Okay, so so I hope you got some idea about this hardware related things, board related things, IDE. So from next session we will work on some experiments on the directly real hardware. Okay, and meanwhile you can practice on the switch that walkv, that is that you can also write the directly C hardware related code as well as the abstract layer based code. Okay, so that actually professor have discussed both type of code in the lectures, and you can try. Okay, but in the lab, actually final course lab, we will discuss all practicals on the board, okay, real boards. Okay, so this is all about this introduction of these things. Now if you have any query you can ask. Okay, so if you have no query, then just explore the documents. Just if you have any board, you can explore the documentation, explore the things, and come with the documents in our board connections in the next session. Okay, you can also write the things or understand the things.
I want
Okay.
to buy the board, so the model you shown, is it sufficient for even the lab, so that I'm comfortable when I come to the lab? There is no change.
Definitely. As I said, na, so most of the STM, if you purchase any type model, so that is actually more very similar to the each other. So, but some features are added, some features are removed, like this. So, but we are learning the basic understanding of the boards. Okay, so we will perform some basic experiments that can be performed on any board, and each type of board support that experiments. Okay, so like communication, some that sensor interaction, like this type of basic experiment we will see in the board. So as I said that nucleo series model you can take. Okay, so which we are using in the walkthrough as well, we are using in the live session, this okay, hands on this session. And I think this time we in the lab we also use the nucleo board. Okay, so nucleo is the best thing if you want to uh,
We
go
will
on
be
the
needing
same.
other sensor equipments also. So, which website is suitable for this purpose? Where we can
And
buy?
there are lots of sensor actually. Time to time, according to your need, you can purchase. Okay, so we are not have any predefined things which sensor we will use. So I'll check in right now in current lab, so which we have already done in this last week. So I'm not aware of this. You can ask to the Suvendu. Okay, so another instructor of this course, you can ask to Suvendu which sensor actually they used, which board they used in the physical lab in the campus. Okay, so actually, Suvendu is managing all these labs part. Suvendu and Levin. So
No, I was asking for the platform where we can buy these things. Can you suggest some?
uh, yeah, there are lots of platforms. Actually, I purchased this platform through some DigiKey. So, but that product comes from the USA, so they actually uh, include some charge for the all the things. So you can also purchase through this from Amazon. So I think that any India shop like this, okay, just search on the net any in India market you can purchase. Okay, otherwise if you will purchase from the outside of the India, they will import uh, many charges on that.
It may take a month or more,
Yeah.
maybe.
It will also take, yeah, correct, the 10 to 20 days like this. Okay, so you can see through the Amazons or Robu.in, like there are many electronics device sites are there. Those who actually provide the hardware through the India. Okay, so you can purchase and compare the price also. Okay, so which actually are providing in the less price. So just purchase only one board like this. Okay, otherwise if you don't want to purchase, then you have to depends on the walkway simulator. Okay, so you can perform all the things on the walkway also, but in that case you will not get the real feel. So because of that I am suggesting, otherwise no, this is not the compulsory things. All things can be done on the online simulator also, and later in the physical lab you can perform on the physical board also. Okay. Okay, I hope all things are done. If you have no query, then we can close the session. Okay, thanks everyone. We'll meet in the next session.
Thank you, sir.
Thank you, sir.
Thank you, sir. It was a nice.
Thank you so much.
Yeah, thank you.
Good night, everyone.
Thank you, sir.